So today, I would like to talk about the digital communications and the measurement, how we use data, use the methodologies to measure the digital communication in our daily life. By the way, I came from Zhejiang University, the Center for Digital Communication Studies. So now I think many of us use the digital apps, social network maps every day. So in China, we mostly use the WeChat for personal communications, and we use DingTalk for the enterprise work groups. And of course, in overseas countries, we maybe use the WhatsApp. And if we have this kind of data that somebody say something at what time, and if we have this individual level data, what we will have, the phenomenon will be quite different. Yeah, this you can see this. We see human dynamics behaviors will be much more different from the natural phenomena or this kind of text. Means that for the text, the phenomena and the natural phenomena, they are more equally with non-correlated behaviors, and the time between the two events are mostly equally, and the distributions will be constant distributions. But for human behaviors, the time differences and time distributions will be much different. Is that the behaviors happen only correspond to the event or response to something like emails or sometimes the speakers. So this is the time between two differences may be very large, and the behaviors only happened in a certain time. And this kind of phenomenon we call human dynamics, or we say Bostonese. How in this kind of digital communication behaviors we can present like in a network way, and with this we can put the edge link, like B and D communicate. We will make a link, and this here we will have the network of the time series sequences with all digital communication sequences. Then, but before we come to the time sequences, we come to the static ones. Suppose there are 3 networks. Most of them have the same individuals, with the 12 individuals of the 12 nodes. But the differences between G1 and G2 is only the one link are different. So, but if we say by eye, we say the G2 and G1 are much more similar. But is that the truth? If we have some measurements, we will find that G1 and G2 have very similar structure, only one link missing, but the differences are quite different. It's almost come to 0.4, and the difference between G1, G2, and G3 even across 1/2. So this measurement is very simple for eyes, but is that true? But we can, I have a daughter of 6 years old, and normally I play with her about these puzzles. So, but when she was young, I see that these 2 pictures are different. Then we make the puzzle and I try to find out the solutions. Very hard. And sometimes our eyes will also cheat us. These 2 pictures are not different, but they are the same if we have them look at the details by some measurements or by some by some AI method. So come to the temporal network ones. So we will see that the digital communication differences can be also be measured by the index we proposed is that look at the picture of A and B. They have the same 5 nodes, but the patterns of digital communication are very, very different. Suppose that at day 1, the graph A node 1 communicates with node 2 and 3, and then the day 2, node 2 communicated with node 3, but the B, in the day 1, node 4 connect with node 5, and in the days 2, 1 connects with 5 and 2 connect with 3. If we neglect the time, we will find the static network that the two networks, the two digital communications are actually the same, the same very much. If we neglect the time, we will build a link if the two nodes have the communication. So actually, it's not. Of course, it's not. So our simple idea is to consider the time, embed the time into the network. We consider the temporal path between two nodes and find that the temporal networks are quite different. So I didn't want to go too much about into the details of the math. So, but this paper we are just the submeter is now under review in Nature Communications. So we will test this network in this method in the real network. We will find that at the f equals 0, it will be the original digital communications, or obviously the original networks. But if the f is larger than 0, it means that we add some digital communications into the all original ones. And we will find that if f less than 0, we will remove the links from the original digital communications. So we will find that for this kind of temporal-based similarity, we can significantly evaluate the difference between the infodemics and the digital device. So we will test this measure for the real data. This is the data from the school. For the school, we listen that this is the data from day 1, and this is data from day 2. Day 3, day 4, day 5, the communications. It means that for if the number is larger, means the difference is very large, and if and vice versa. So we can see that the differences between the similarity between the long-term, the difference between long-term communications is larger than the short-term communications. Okay. So, and we also embedded in this, apply this measure into the information severity. We will find that if the two digital communications difference are larger at the x-axis, and the information severity will also increase. Okay, so another interesting result we use this index is that we found that we apply this index in around 17 data sets around for 4 telegraphs. One is the 5 data from email networks, and 6 data from visitors galleries, and 4 data from high schools, and 2 data from conferences, face-to-face communications. So originally, this if we use the static network, we will find this. We will see these networks will be in the same category if we can classify by the content. But however, if we classify by the digital communication patterns, we will find that this, how to say, I cannot reach as high that. So this with is EU3 is a email network, but its classifier at last its classifier is akin to the high schools and the conferences, but not as close as the other four email networks. This means that even this data comes from the similar communities, but the patterns of communications are not the same at all. They may be talking different styles, maybe talking about different patterns. So this, although they are same people, they are talking the same topics, but there are 2 different classifications. Oh, sorry. So the potential, the potential applications of our index is now, I think it's going to be large. So we, of course, the first one is we can identify the how to say the network effect of the advertisements in how to say WeChat. Yes, WeChat likes. So if it's easy to say that we can, by my friend is they can easily, how to say, configure the Democrat graph factors in the experiments, but however, they cannot control the network effect in experiments. So how to integrate this? How to evaluate the network effect as a variable to measure our experiments or the statistics is an important problem in the statistics, in the real experiments or online experiments. So our method give a promotion way to evaluate this one. And also this kind of index can be applied in this, obviously, the digital resistance or digital device and urban resistance, something like that. Okay. And last but not least, I will make a small advertisement of our center. This center is founded by Professor Huang Dan in 2020, 4 years ago, and yes, and we have. If you are interested, please contact us via this email or this come in person. Okay, thank you very much.